Okay, so competitive inhibition, big thing between, or the big thing to understand is that substrate and inhibitor, they're fighting for the exact same slot on the enzyme binding site. So at a high substrate concentration, there's going to be no inhibition because there's a competition going on between the substrate and inhibitor. And if there's too much substrate, the inhibitor can't bind. Because there's no inhibition at high substrate concentration, your Vmax is going to stay the same. On the other hand, the competitive inhibitor works best at low substrate concentration. So at low substrate concentration, here's what's going to happen. There is going to be inhibition, and because of this inhibition, it's going to appear like the enzyme doesn't have as great of an affinity. It doesn't have as great of an affinity. That's why we're going to see a raise in the Km value. So Km apparent goes up. And Km apparent equals alpha times the true Km. This value alpha is equal to 1 plus the inhibitor divided by Ki. And Ki, it's a measure of the dissociation between enzyme and the inhibitor. So E times I divided by EI. Okay. Now, a couple of graphs that we want to be aware of. For looking or to solve for the true Km, we can plot Km apparent versus the inhibitor concentration. And the thing about the y-intercept is it needs to be equal to Km because that's when you have zero inhibitor. The slope for this graph is going to be Km over Ki. And the equation that we're actually plotting in this scenario is going to be Km apparent, I'm writing it in orange, equals Km over Ki times inhibitor plus Km. Okay, so purpose of this plot down here is if you want to solve for what the actual Km value is. Next thing, let's take a look at velocity versus substrate concentration. So uninhibited, I put this in green. We have a Vmax, and what's going to happen is Km is when Vmax is equal to, or when Vmax, Km, or Vmax over 2 is when Km equals the substrate concentration. On the other hand, if you have an inhibitor, eventually you're going to reach the Vmax. It's just the Km value, the Km apparent, went up. All right, so there's no change in the Vmax. It's just obtaining half of that Vmax is going to be harder because you have some inhibition going on at lower substrate concentrations. And then the last plot that we want to look at is the Lineweaver-Burk plot. So remember that this is a straight line. The slope of the Lineweaver-Burk plot is going to be Km over Vmax. Y-intercept is going to be 1 over Vmax. And then the x-intercept is going to be -1 over Km. On the other hand, if you're looking at the presence of the inhibitor, Vmax does not change. Okay, the x-intercept is now 1 over alpha Km. The Km went up, so the intercept gets closer to the origin, and then basically you made the slope more steep because slope is equal to Km over Vmax. You kept Vmax constant, but you raised Km. Because you raise the Km, it becomes a more steep slope. So one of the giveaways on a Lineweaver-Burk plot that lets you know you're dealing with competitive inhibition, same y-intercept, but the lines become more steep as you add more inhibitor. Okay. And then actually one thing that I forgot to mention, this isn't Km, this is Km apparent, okay? Or alpha Km, whatever notation you want to use.